Afternoon. Let's start the third stage of the Physics 5. First, we are going to introduce our jury. My name is Chen Hongyi from the National Taiwan University.
My name is Typt from National Tsinghua University.
Yeah, we're from National Central University.
Then, we use a reporter, opponent, and the reviewer. So, the captain introduce your team, your member.
I'm representing all the competitor. I'm the leader of Team 00 Hou Yiqian. And here's my teammate, Wu Yizhen, Chen Liangyi, Wu Hanxu, and Zhang Yiqian.
Opponent.
Everyone, we're Mingdao Ming. I'm from Mingdao High School. This is pretty cool. We need to learn Jerry Cow and Darku, and I'm Robert Lin. Thank you.
Reviewer.
And hello everyone, we are Team ECN 1917, and I'm Zhen Zixing, Wu Yujing, Chen Liuyu, Zhang Huiyu, Jiang Yunyu.
So, where are you from?
National Zhanghua Girls Senior High.
So, now let's start our Physics 5. We have 1 minute for the opponent to challenge your reporter.
We want to challenge question number 1, fractal figures.
Reporter is 1 minute to decide you successful or reject.
We accept.
Accept. So, reporter, you have 5 minutes to prepare your presentation. And captain, please write down the representative on the blackboard. reporter is ready, so you can start your presentation.
Hello, voters and fellow consumers. I'm the reporter is today I'm going to report on number 1, fractal fingers. Here's a long segment. The effect of fractal finger can be observed if a droplet of an ethyl alcohol mixture is deposited onto diluted and light paint. How are the geometry and dynamics of the fingers influenced by relevant parameters? And we will mainly focus on the formation of the fingers and also how the geometry and the dynamics of the fingers influenced by relevant parameters. For example, concentration variation and the volume of the mixture. And here's my outline. First, I'm going to show you the observation video and also the quantitative explanation. And I'm going to show you the quantitative theory and our experimental setup, and also the experiment, and finally is the conclusion. And here's the observation video. As you can see, the medium concentration of alcohol will expand and transfer into fingers, and the range of the medium concentration will be about 12% to 70%. And lower concentration of alcohol will expand, but it won't transform into fingerings. And high concentration of alcohol will expand and transform into fingers. However, the fingers will be too thin. That can be observed. So we are going to use the medium concentration of alcohol to do our experiments. And here's our qualitative explanation. Here's the definition of the radius. We define this part as the initial drop, and here's the radius of the initial drop. And the temporal evolution of the initial drop radius will be looked like this. And because that's when the radius expands, it will tend to stop expanding. So we will define this part as the maximum radius. And here's the definition of a finger. We define this part as a finger, and this part is the length of the finger. The temporal evolution of the length of the finger will look like this. And the length of the finger will be defined as the length deducting the radius of the initial drop, like this part. Okay, so I'm going to introduce to explain the physics behind phases. The first stage is the gravitational effect. When the drop is deposited onto the diluted paint, the drop will be influenced by the gravitational force. The surface tension is not strong enough to hold it as a spherical drop, so it will flatten like this. So you can see that the thickness at the center will be bigger than the rim. And because of that, after it evaporates, the concentration at the rim will be lower, which means that the surface tension at the rim will be higher and cause the surface tension gradients and cause the magnetic flow to flow from the center to the edge. And because we define as the surface tension is gamma and the concentration of the mixture is phi, and because that the system will tend to minimize the surface energy, so it will try to expand and increase its surface area. So it will start to expand outward. But when the surface tension of the interface of the interface is lower or equal to the surface tension of the diluted alkylic paint air interface, it will start to expand. And because of the surface tension, the thickness at the liquid at the boundary here and the radius here in this part, the ring will form an ultra-thin liquid flow region. And because the system will try to remain the lowest surface energy, so the ring will need to increase the surface area. So it will transfer its edge from the smooth edge to fingering edge. And because as I mentioned, the system will try to remain the lowest surface energy. So the ring will need to decrease its surface area. And the edge of the mixture can be described as a Typt state function. So the edge will be disturbed, like this part, the finger will be disturbed, and it will transform into more small fingers. And because that the mixture and the diluted paints are all surfactant, so it will interact into the paint. And so this part will have minimalized surface tension. And the interface between mixture and the diluted paints will be blended together, like it will mix. So the viscous force will influence the system. So it won't split into more small droplets. The finger will and it will transform into more small fingers, and the finger will keep expanding until the alcohol evaporates and the magnetic flow declines. And here's my quantitative theory. We define the viscous forces like this, and so the viscous stress will like this. And the surface tension will be defined as the viscous the viscous force divided by the characteristic radius. And we assume that the mixture can be viewed as a single interface with an effective tension. So the delta gamma will be the mixture air interface surface tension minus the paint air interface surface tension. And after calculating, we know that the delta gamma, which is the surface tension gradient, will equal to like this. And because the variation of the surface tension will be triggers the mercury flow, so the delta gamma will be defined as the critical concentration of the mixture's surface tension minus the initial concentration of the mixture's surface tension. And if we ignore the evaluation of the paint, the variation of the volume of the mixture will be looked like this. And after calculation, we know that the characteristic radius will be looked like this, and it will be proportional to the maximum radius. And we are going to do the parameters such as concentration, the thickness of the paint, and the volume of the droplets in order to collect our experimental data. And here's our experimental setup. We use packages to fill our paint, and we put it on the heating plate to remain its temperature. And finally, we cover the whole system with plastic board in order to avoid environmental affection. And here's our measurement. After measurement, we found that only the max fraction will be the boundary limits of this experiment, and the boundary limits of the concentration will be the lowest concentration will be 12%, and the highest concentration will be 70%. So we are going to use concentration between this range to do our experiment. And we also measure the evaporation flux in order to collect our experimental data. And here's our first experiment. When the concentration increases, which means that higher concentration will need more time to evaporate to critical concentration. So the radius will have more time to increase. So the maximum radius will increase when the concentration increases. And because of the maximum radius increase, so the finger will have less finger to expand. So the length of the finger will decrease when the concentration increases. And after compare, we found that the length of the finger and the maximum radius will have negative correlation. And the next experiment is about the initial volume of the mixture of the droplets. And we know that the larger volume of mixture will need more time to evaporate, and also means that the radius will have more mixture to expand, so the maximum radius will increase. And so do a finger, it will have more mixture to expand, so the length of the finger will increase. And after comparing, we found that they will have positive correlation. And the final experiment is about the thickness of the paint. Because of the mercury flow, when it flow forward, it will trigger the paint downward to flow along. So it will cause a boundary layer of the paint and also cause a high flow to compensate the boundary layer. And when the thickness of the paint decrease, because the boundary layer's thickness is fixed, so the system and the energy of the system is also fixed. So when the thickness decreases, the high flow will need to be faster. But since the energy is limited, so the system will tend to decrease all the velocity of the flow in order to balance the energy cost. And because we know that when the thickness of the paint decreases, the flow velocity will decrease, which means that the mixture will evaporate before it expands outward. So the maximum radius will decrease when the thickness of the paint decreases. And since the maximum radius decreases, so the finger will have more mixture to expand. So the length of the finger will increase when the thickness of the paint decreases. And after comparing, we found that the length of the finger and the maximum radius will have negative correlation. And this is the relation between maximum radius and length of the finger with all the different parameters. And we found that only when the parameters, only when the volume is the parameters will have positive correlation, and when the concentration and the thickness of the paint be the parameter, it will have negative correlation. And here's our conclusion. The physics behind this thesis is that the gravitational force will make the droplets flatten, and because of evaporation, it will cause surface tension gradients and also cause the mercury flow to flow outward. And because the system will tend to minimize the surface energy, so it will transfer transform from smooth edge to fingering edge and to more small fingering edge. And because of the disturb as the edge of the finger, so the finger will transform into more small fingers. And the finger will keep expanding instead of splitting because of the viscous force holding. But it will slow down since the mixture evaporates. And the surface tension gradients will be decreased, and the meridian flow will decline. And here's our conclusion of the experiment. When the initial concentration of the mixture increases, the maximum radius will increase because it has more time to evaporate. And the length of the finger will decrease because the volume is limited. And the relation will be negative correlation. And when the initial volume increases, the maximum radius will increase. And because of the volume increase, so the finger will have more mixture to expand, so the length of the finger will increase. And after comparing, we found that it will have positive correlation. And when the thickness of the oil decreases, the flow velocity will be slower, so the mixture will evaporate before it expands outward, so the maximum radius will decrease. And since the maximum radius decreases, the finger will have more mixture to expand, so the length of finger will increase. And it will have negative correlation. And after comparing, we found that only a parameter is the volume will have positive correlation. And when the parameter is the concentration and the thickness of the oil, the relation will have negative correlation. Yeah, here's my report. Thank you for listening.
Paula, can you question the report or not?
So why do you think when the concentration is too low, it cannot spread?
Because when the concentration is lower, the surface tension will be bigger. So it won't cause surface tension gradients to cause the meridian flow to flow outward. So the phenomenon won't happen.
Do you think the alcohol can use interior acrylic?
The acrylic paint, the ink will mix into the acrylic paint, but the alcohol, the alcohol won't mix into the diluted paint down at the bottom.
Can you show me the theory when you're completing the maximum radius? I believe I've seen that part somewhere before. If you are a side of the law and which side from your other side.
Yeah.
And I think I have seen this before. Is this from your citation or you derived it for yourself?
This is our theoretical.
Theoretical.
We found this from your process.
Okay. So next time I think you can see your citation. And can you transfer experimental demonstration video to video? Why does it and it has different angle of shooting?
What do you mean different angle of shooting?
Oh,
this is the camera's angles difference. But when we drop the droplets, the syringe will be vertical.
the syringe will be. So you should
So
go
sit
from
on
the
this.
angle.
Yeah.
So you should run the angle.
We should find the angle, yes.
So do you calculate the velocities of the fingers?
We didn't calculate the velocity of the fingers.
But you know that most of the dynamics is talks about the velocity, rather than just a velocity.
But we think that because the velocity of the fingers will like the form of the fingers and the development of the finger will be very.
Time's up. Now it's the time of report's preparation. the floor, please, and start your presentation and discussion.
Good afternoon, honorable judges, my partners, and my competitors. My name is Bo Yu, and I'm running from down the end. Today, the topic I'm going to upload is the fractal fingers, question number 1. A couple statement, fractal fingers. The effect of fractal fingering can be observed if a droplet of an ink alcohol mixture is deposited onto diluted acrylic paint. How are the geometry and dynamics of the fingers influenced by relevant parameters, and the purpose of formation of fingers and relevant parameters. So in the theory, we have mentioned about the gravitational effect and the surface tension. Directly for the ultra-thin liquid film region, the surface energy difference, the heavier side function, the influence of surfactant and viscosity. And for the setup, they have used the acrylic paint, the isopropyl alcohol, the petri dishes, and the pipette, and of course the shooting camera. And for the parameters, they have fixed the temperature, and also they change the concentration, the volume, and the thickness of the paint. And for the analysis, they have discussed about the relation between the parameters and the maximum radius. For example, when the volume goes higher, the maximum radius goes higher as well. And for the concentration and thickness, if it goes higher, the maximum radius will go down. Next page. And for the conclusion, they also have talk about the fingers relationship with the other parameters. Next page. And we think that their advantages include good demonstration video and quantitative method and explanation for the first diffusion. And some of our suggestions include that they could probably have clear experiment setup, and also slower the pace to explain every graph, and also be clear as well. And next one, we don't think they have enough variables, which we will talk about later. Next page. So as for my points of discussion, we would like to focus on the different materials they use, and also the fingering boundary, and also the characteristic of the phenomenon. And also, when they fix the temperature, what will happen to the evaporation. This is much of my opponent presentation. Thank you. I will start the questioning section. So first of all, I would like to talk about the definition of object. So as you can comment here. In the alcohol mixture is an object onto the other. However, acrylic is not only a kind of liquid. We know that alcohol is acrylic. So actually, alcohol, if you know what is alcohol, it can also be called as alcohol. So alcohol is not only pure alcohol. It can also include alcohol and some other solvents, other solvents.
Yes, so due to the problem statement, we just use the common alcohol to do our experiments, because the problem statement has mentioned that we use the ink alcohol mixture to do our experiments.
So alcohol is actually not only one alcohol.
I mentioned that because the most common.
So I think this question includes the other variables. And next page, when you were showing the what was that called? The equation that resembles the Young's equation. The Young's equation. Okay. Yeah. And I noted that this is not are you referring to the acrylic here, or this is just a stable place?
Oh no, this is an acrylic.
Acrylic.
The diluted acrylic mix, which is mentioned in all the statements.
However, the opponent thinks that the acrylic can actually fuse into the alcohol, since alcohol is a polar solvent. A harder solvent is a kind of liquid that contains the characteristics.
But since the evaporation and the membrane flow is influencing the mixture of its bending, so we think that the reporter believes that when the alcohol mixed into the paint can be ignored.
However, it's actually contained the characteristic of being hydrophilic and lipophilic alcohol. So I think this is not something that you should ignore, actually. And interfacial tension between this and this?
Because this part, the ink and the mixture will mix together. And also, we have mentioned that the ink and the pumpkin are also both surfactant. So, can I use the backbone, please?
Yeah, of course.
So, when the mixture is also out of the ink,
Yes.
so this part of the interface, it will have both the mixture and also the ink. So this part we know that the surface tension will be minimized. So this part we can don't consider the surface tension in this one.
Well, however, do you think when it's generating the fingers, its interfacial tension will also be limited?
Which interface?
When generating the fingers, the interface that generating the fingers, its surface energy will also be the minimal.
It will tend to minimize the surface tension. So it will start to decrease the surface area of it. So like I mentioned in the report, it will change from the smooth edge to bigger edge.
Can we have the next page with showing the tip splitting part? Tip splitting. Yeah, like this. So we were saying that here is creating its surface area here.
Okay, I can explain.
Okay, I think you explain. Yeah.
So when the finger is generated, this right.
Yes.
So the variable flow will flow this way, and because we know that when we observe, for example, the finger will look at this way, and which means that the the finger is vertically will look like this, and in the center part,
Yes.
the finger will be bigger, right? And the
Yeah.
bigger, and the rim part it will be bigger.
Yeah.
And so it will also have surface tension gradients, which I mentioned in my report in this part. So it will also cause a surface gradient which causes a magnetic flow this way.
Oh.
And also this way. Okay. So when this part has reached the critical concentration, which means that the length of the finger has started to expand.
Yeah.
But here we'll also have working flow, and because of this, so it will like generate into more small fingers like this.
However, as you mentioned, the apple will actually evaporate. Is that correct?
Yes.
So when it's tip splitting and it's also evaporate, why with here also generating the tip splitting process? Okay, so you mentioned about when reach a critical concentration in here, probably.
No, when it's reached the critical concentration, it won't expand anymore from this part.
So in each tip splitting.
When it's generating the fingers or expanding the length of the finger, it didn't reach the critical concentration.
Okay, so the opponent here wants to provide a different perspective. So we think that when you first create the fingers from your maximum radius, it actually has a positive curvature and a negative curvature. And after the flow proceeding, it will cause a higher curvature and more and more curvature.
You mean there will be a flow from here to here?
No, I mean curvature. Curvature. Yeah. So when the curvature reaches a certain point, the surface tension will actually be high. Because surface tension is a thing that can stabilize the system, so it will divergent. In order to decrease its contact area with the acrylic, so their contact area's energy will be lowered. So this is why it kind of like a decelerator process.
But if the finger has expanded, so it will be like thinner, right? So
I don't think so. I mean in the same layer where now tip splitting is splitting my
so when you are mentioned about the surface energy from the fingers parts, right?
Yeah.
So if before the finger will look like this.
Yes.
And as the volume is limited, so when you expand, the thickness of the finger will be thinner like this when the volume is limited. So when we assume that the length from here to here is equivalent. So we can know that I assume that this part, this interface, the service function is, because it's smaller than this part, because this is the case.
Yes.
And this is the mixture. So we know that this part service function is slower, right?
Yes.
So we know I assume that this part is maybe 300, this part is 500, and now it's also 300. And because the length is equivalent, right? So if from this part I assume that here the length is maybe the length is 1. Okay, so and here is maybe 1.5.
Proceed faster a little.
Okay, so it's 1.5. So after calculating the service function, we know that because the service function is has a relation to the service area. So after calculating, which is actually bigger. Here is 800, and here is
I think you probably have something.
So the service energy will actually be lower than when before. So we know that the service energy will be minimized.
But you didn't calculate it here because you probably regarded it differently. So here I will move on to the next question. Can you move on to the calculate your calculating the dynamics of the figures what the carbon statement has mentioned? No, I don't think you have to do this because our dynamic part of the carbon statement.
Can you provide the exact number?
I'm sorry, I think it's later. Like the carbon statement asks you to analyze the dynamics and the geometry of the figures. So dynamic of your data.
Data.
Yeah, your data about the dynamic of the figures.
Here.
Okay, so you didn't actually calculate the velocity, right? As we have talked about.
So in our observation video, we found that page 4. So we know that because the expand of the mixture, which also means that the velocity of the mixture, like when it can expand, the radius can expand and just fall into figures. We can know that when the concentration is
Well, however, do you think it's a constant velocity? Do you think it's a constant velocity in the figures generated?
It won't be. Maybe not. Actually, it will be.
Yeah, but mentioned it's not constant. So this is why you shouldn't calculate the maximum amount and try to divide it by.
You mean I shouldn't calculate what?
The length. I
The
think
length of the figures? Why? Because we think that to analyze the length of the finger can know that.
Try to calculate the slope.
But the reporter believes that when we calculate the length of the finger, we expect to one.
Okay. So like I mentioned before, I think you probably have some energy loss in this process. So it's an acceleration. So this is why you should do the dynamic like this. And for the geometry part, you have the data for your geometry. So for your geometry, okay, so for the geometry, we think that
Time's up. It's time for the opponent to summarize the discussion.
So in this part, we have talked about the characteristic of the alcohol and its chemical characteristic as well. And we'll talk about the methodology to calculate the dynamics, and also our perspective on Typt's living process that mainly causes fingers to be fractal. Yeah, because the fractal means the new derivatives resembles the original ones. So this is much of my report. Thank you for listening.
The reviewer, you can question the reporter and the opponent now.
So first I want to ask both reporter and opponent, do you think what is the main reason that caused the droplet incident?
The reporter believes that the American police.
I think it is
the spreading coefficient, which can be derived into the difference between the surface tension.
Okay.
Yeah.
And do you think that what caused the Java particle?
You mean fractal is more small because
Yeah.
the system will try to analyze the surface energy.
Okay. I think it's about the first principle of the minimal surface energy, and the kilojoule mole, and the 7 kinetic stability, and the carbon Helmholtz instabilities as well.
Okay. So, do you think that the diluted articulate hydrophilic or hydrophobic? Diluted articulate and hydrophilic or hydrophobic? And hydrophobic. Okay. And do you think that the alcohol is hydrophilic or hydrophobic?
It's
It also contains a little characteristic acid.
So you think that one is hydrophobic if one is like
Yeah.
so you think
It's a
we
function
should consider diffusion
diffusion
between the two liquids.
Between, yeah, you can consider diffusion. Fusion, yes.
Okay. And so did you control the temperature in your experiment?
yes, we using we put the place on the.
Okay. And the humidity.
We cover the whole system with the particle in order to control our system.
How do you define your dynamic part in your experiment?
We believe that the dynamic parts can be analyzed like the Lincoln and the development, and also the maximum the development of the radius of the system.
I think it's a design process, so what you should do is shoot the video and try to put into analysis software to track it.
Oh, okay. And do you test the viscosity of the?
Yes. So we have calculated the viscosity of the paint in order to calculate our theory line in our chart.
So do you think that inner circle radius and the fingers will just expand both like at the same time?
So when the radius has expanded outward and it will reach its maximum radius, and the finger will start to expand, and actually the radius is stop expanding, and the finger will pull the radius outward. So actually, the radius expand, stop, and the finger will expand.
Like the inner circle radius and the fingers will like expand like at the same time.
I think no. Because when you reach the spreading coefficient is zero,
Time's
so
up.
that finger can start to spread.
It's a time of a reviewer's preparation. Reviewer, text the floor, please.
Hello everyone, I'm Duri from Team ECN 1917, and that I'm going to review to you. Problem number 1, fractal fingers. And here's the problem statement, and we think that it will be mainly focused on the process of the droplet fractal and the evolution of the size of fingers, and the geometry and the dynamics part of the fingers. And here is overview of the reporter. We think they investigate the evolution of the finger, will cause different kind of concentration, and will produce random flow from from lower concentration to higher concentration. And the definition of the radius and fingers, it is because of temporal evolution. For theory, they got random effect, concentration gradient, surface tension gradient, and gravitational effect. And also the surface energy difference between the different interference shapes and step functions and influences of surfactance and viscosity. For experiment, they changed 2 parameters. One is the concentration of alkyl mixture, and one is the viscous effect of the pinch. For conclusion, the gravitational force causes the fractal of the liquid, and magnetic effect causes the droplet expand. And when the thickness of the pen decreases, the maximum of the radius decreases. So for practical well-phenomena explanation, like the evolution of the fingers fractal and the definition of radius, and investigate sticks to a property with the geometry and dynamics of the phenomenon. Well, but I think that it's not enough, since for the dynamics they should just consider the length, but we think that it can consider like the width of the finger or the dynamic of the finger, and lack of the explanation how the theory has a proportional relationship to experimental results and the theory, and with other sources. So for overview of the opponent summary, the material of the liquid, they discussed that if we use alcohol and ethanol, relatively different, and both mixture are also, if they have diffusion, we have to consider the interaction between. And for discussion of how magnetic effect of the droplet expand, and discussion about force put out of droplets, it is because of disintegrate gravitational force, and then but for concept discussion of the dynamics of the mono droplets, only talk about the fingers only. So discussion, opponent asks what is the main reasons that cause the droplet fractal, and reporter said the surface tension difference in the gravitational force. And also the opponent said that it is also caused by self-entire instability and Haber-Holz instability. But we think that Haber-Holz instability is a kind of instability occurs with only 2 surfaces, but with different velocity. But it is vertical. However, in our experiment, it is like horizontal. And for self-entire instability, it will only occur in telescope, which is between the 2 plastic plates. But in our experiment, it is between the equipment and the air, so we don't think that it will be using this phenomenon. We think that it is because of turbulence, and it will cause temperature difference and pressure difference, and so that causes fingers. For the discussion, 2 kinds of liquid are also hydrophilic too, so do you think that we have to consider the interaction between it? Reporters say we have to consider it. We both think that 2 kind of mixture will mix together, so we have to consider the diffusion of it. So since that will fasten the speed that droplet expands. Here's the basic point for reporter didn't consider like diffusion, since it will affect the speed that of the droplet expand, and didn't investigate the dynamic part. Like
time's up.
Yeah, thank you.
Reporter, start your concluding remarks.
We did experiments with the same shooting angle with using a syringe since the data has shown that. And when the concentration is small, the surface tension is too big, so the finger will start to expand. And with the meridian flow will drag the finger outward, so it will expand outward when the radius reaches critical concentration. And we disagree with the opponent since we believe that the cause of the finger and the expansion is the meridian flow, and the system will try to minimize the surface energy, which causes the mixture to fractal in the fingers. And there's a high surface tension at the rim of the finger that the finger will start to expand. And the fractal fingers are caused by the system want to minimize the surface energy. And we think that telescope can't Herschel's law can explain the phenomenon since its main driving force is pressure from the parallel plates, which the Herschel's pressure is the pressure from the parallel plates. But we think that the flow and the mixture and the paint is not parallel, which means that the Herschel can explain this phenomenon. And the maximum radius and the length of the finger won't expand at the same time, which has I mentioned that when the radius reaches critical concentration, and it will start to expand, and the finger will start to fractal, and it will pull the radius outward. So it will look like it's expand at the same time, but actually it's the radius expand, the radius stop, and the finger expand, and it is the end of the phenomenon. And here's my concluding remarks for this.
Now it's time for the jury to ask questions.
Okay, so I got two questions for all of you. First one, why this phenomena is called fractional fingers? Okay, why not just called fingers? Okay, why there is some kind of what kind of meaning for this word? Okay, that's the first question. And then the second question is, if we calculate all the lengths, okay, the whole length of those fingers, okay, because it keep copy the form of itself, right? So it will expand the length. So will it go to infinity or not? Okay. Because you have fingers, right? Then you grow, right? So you will expand your length, right? So you keep growing, keep growing, keep growing. Let's assume it just keep growing. Okay. So will it go to infinity or not? Because in some sense, if you look at the whole picture, you will confine in some kind of area, right? You will confine in some kind of area. But in the reality, when you observe it, it just keep growing. So my question is the final length, the whole length, okay, the whole length of those fingers, okay, will it go to infinity or not? Okay, good question. Yeah.
Okay, so for the first question, I want to ensure that the question is why the fractal fingers will be called as fingers. So the author agrees that because that when the radius expand and fractal into fingers, it will like this. So maybe that's why it's called the fractal fingers. Okay, so for the next question, the reporter believes that the fingers won't grow infinity, like because that the alcohol is evaporating. So when the alcohol evaporates, it evaporates into it tends to more like water and ink. And when the surface tension gradient is not enough to cause a meringue flow, the expand of the finger will stop and cause the end of this.
No, I'm assuming if we just keep growing. If you always have sufficient concentration, okay, let's assume you have sufficient concentration, you just keep growing, then will it go to infinity or not?
We believe that if only assume that it will always have surface tension gradients, but the quality and the ink at the bottom parts will dry into it's not fluid anymore, so it will also have the end of this.
Okay, so review.
So the first question, looking that it is called fractal fingers. So fractal, we can use like the dimension of it to explain it. Since like a line, it will be like one dimension, and a flat, it will be like two dimensions. But for fractal, it is the dimension between 1 and 2. So it calls fractal since there won't be a flat. It will never be the full of the flat is 2 dimensions. So it is called fractal fingers. And for the second infinity part, we're looking at the volume of the actual.
If you keep going, grow. Okay.
But we think that the length that every fingers, every layers of the fingers will be smaller and smaller and smaller.
No, length is one dimension, right? Length is one dimension.
One dimension.
Yes. So just keep growing, right? Keep growing, so you will increase the length. You always increase the length.
Okay.
But it's always confined in some kind of area, right?
Yeah.
Because it's smaller and smaller and smaller.
Yeah.
But length should increase. Area is not increase. So let's go to infinity or not.
If just maybe yes.
So for the first question, I think the definition I found for fractal is the new derivatives of a system that resembles the original ones. So like the instabilities I mentioned before, like the segmental instability and the Kelvin-Helmholtz instability, which I found, they actually generate the similar shapes at a time. Yeah, they actually generate a similar shape. So this is why we think that the branches or the fingers that generated by it can all be seen as fractal. And for the second question, I think it wouldn't go to infinity, since it's actually a decelerating process. So when the fingers keep growing, it will tip splitting, and the curvature under the acrylic surface will actually get higher as well. So the contact area of it and the acrylic will actually get smaller. So as the contact area gets smaller, the interaction of the molecules under there will actually go smaller as well. So this is why its energy is decreasing and also causes the deceleration.
Okay.
More questions? Yeah, also three questions for you guys. Do you think for reporter, do you think chemical reaction plays a role in those chemical reaction does it play some role in your
We think that the chemical reaction will be outcome will affect the experiments. Like it's elaborate on the vapor measure of the outcome will affect.
Are there any chemical reaction in your experiment?
We think that there's no
chemical reaction. What do you think?
I think since the alcohol, like I mentioned, is a polar solvent, so it can actually fuse itself, the ink, and a little bit of the acrylic at the same time, though the percentage is not high, but it will still fuse. So this is why we think the chemical reaction actually affects this experimentation. Yeah.
One thing that for the acrylic paint, before it dry, it can mix with water. So like might be hydrophilic, and the alcohol it is also hydrophilic, so they may mix together. So here we have to consider the diffusion of the two.
So we have more questions.
I have a question for the recorder. So you mentioned mixture evaporate in this term several times to interpret your result, right? So how are you going to justify mixture evaporate? You mentioned mixture evaporates several times, right? To interpret your result. So how are you going to justify the mixture to evaporate?
We measure the evaporation flux, which means that we know that the mass of the mixture will decrease after time passes on. We know that the evaporation will affect the experiment like this.
They don't know which part of the sample, right?
I can't really
Can you narrow down which part of the sample?
which part of the system.
Yeah.
When
I thought you mentioned it's in the fingertip, right?
Huh?
It's going faster in the fingertip. I recall next one you said, right?
faster in the figures.
Yeah, the tip of the finger.
Oh, I say that it has the direction of the flow, but it won't have evaporate faster as the bigger stick is. Like the evaporation rate is always the same since the concentration is the same. But when the concentration has changed, the evaporation rate will change. So it will be depends on where what the concentration is.
So do you have further question? Okay. So now it's time for pouring. So please show the score for the reporter. 88677. Now the score for the opponent. 89697. The score for the reviewer. 88687. We have Joe, you want to give a comment? Okay. Professorship.
Okay. I would suggest the reporter to go slower by cutting down your pace. Okay.
Okay.
It's also important to organize your talk to show the key result, not all the results.
Okay. So let's take a 10 minutes break. So opponent, you can challenge the reporter. Now.
And we would like to try problem number 15, 10-page rotation.
We accept the challenge.
Reporter accept. So now the reporter has 5 minutes to prepare their presentation. you can start your presentation.
Good afternoon, esteemed judges and fellow debaters. My name is Jerry Gao, and this is my problem that I'm going to report. This is my problem statement, and we are going to focus on the regular parameters that causes the ball to move co-directionally or the opposite direction. So this is my experiment setup. We use tractor for analysis. So this is my demonstration video, and my container's wind direction is always counterclockwise. So if you take the trajectory of one ball, you can see that it is also moving counterclockwise, which is called rotation. And if you look at this case, it is moving clockwise, which is the opposite direction, which is called counter-rotation. So why does this happen? First of all, I would like to show the first diagram of the ball. There will be gravity, of course, but because I wanted to draw a force that comes out, so I didn't put gravity on there. So there will be the normal force at the bottom of the container gives the ball, and friction along with it. And since I am in a non-inertial force, a non-inertial frame of reference, then I would have fictitious forces like centrifugal force and Coriolis force. And also there will be a normal force that the wall gives to the ball, and also the friction along with it. And most of the forces will go through the center of the ball. So the pink arrow can create a torque that allows the ball to spin. So when I add more balls inside, there will be forces between balls, and I believe that they will not fully cancel out, but most of the forces will cancel out. And we'll discuss that later. And when the balls reach a certain quantity, then it can be seen as a big cluster, sort of like a rigid body. And this is stated in these papers. And although we can see it as a big rigid body, but it is actually still not in a solid state. So we would have to calculate the error. So if I can see the whole thing as a big cluster, then as I said, the pink force will create a torque, right? So as it's moving around the container, it will still also spin at the opposite direction. Which, when I trace one of the spot on the big cluster, then it will result in counter-rotation. And here are some videos and animations to make me clearer. As you can see, this is still, the center mass is still moving counterclockwise, but if you trace one spot of the one spot of the cluster, then it is actually moving clockwise. And I experimented in my own. I did another experiment on it. See, the center mass is moving counterclockwise, but if you trace one trajectory, then it is moving clockwise. So let's see if this is true. Back to my demonstration video, you can see that the balls are moving this way. And there will be two cases that will be circling around the container. And sometimes the ball in the outside move inwards and move outwards again. This is because that it cannot be really seen as a solid state. The particles of the cluster will move apart from each other, so creates so it might move inwards. But even though it is moving inwards, it doesn't change the direction. Like even if it moves inwards, it's still rotating counterclockwise or clockwise. And according to my problem statement, I have to define the parameters of my counterclockwise and counterclockwise. So I believe that this wouldn't matter too much. So let's focus on the first case. Now there will still be three cases, which is this. So when this speed, like the force that is trying to crawl around the container is bigger than the rotation speed that the centrifugal force is giving it, then it will result in counter-rotation. When it's the same, then it will circle in place, and we'll have like close to zero angular velocity. When the self-spinning speed is smaller than rotation, then it will result in rotation. So here are my methods. According to what I've said before, important factors would include friction, which is affected by radius and density, and the coefficient of friction, since it is normal force times the coefficient of friction. And the cluster movement, the cluster radius, the ball radius, the number of balls, and the container radius will all affect the cluster movement. So these are all being very variables. And the container movement is the rotating speed. And another container movement would be the radius of its movement. But in my machine, I cannot alter the radius, so I do not do that parameter. So here are some prerequisites, and stated in this paper. The cluster rotation, if you can see, is all that. The center of mass is this, and the cluster radius is the container radius minus the distance between the center of mass and the center of container. So this might include an independent variable, like different rolling speed and different quantity of balls. So when I have two different things, this is the container angular velocity, and this is the cluster angular velocity. And when it's less than 0, then it means it's counter-rotating. So I put it, this is a little bit hard to observe, so I separate it into 3 cases. The first case is 16 balls and 17 balls, which is, they never resulted in counter-rotation, which I believe is because of, there aren't enough balls to let it be seen as a cluster. And here are its respectively. And here are 18 to 24 balls. It first goes down and then goes up. I believe it's because it is something like what I said before. It's the rotation speed minus something. And one is affected by omega this way. One is this way. So when it minus together, it will become that, which actually quite fits in, since it is like omega. So this like this or this. Except the centrifugal. And yes, it actually quite fits. And here are the results respectively. And the experiment 1 is this. The last part is this one, which we actually don't see really it still have the same tendencies, but it's a little bit more chaotic, and the error bars are bigger. Oh, so the first case is because there are not enough balls. It cannot be seen as a cluster, and we're never counter-rotating. And the second case is because it cannot be seen as a cluster, and the slowing speed provides both the spinning speed and the rotating speed. So that's yes. And the third case is there are too many balls, chaotic energy, but they still have the same tendency. So one question derives, in what conditions can the ball be seen as a cluster? So I did another experiment according to this, which is my second experiment. The independent variable is the different container sizes and different ball sizes. And this is the number of balls added to cause counter-rotation, the least number of balls added to cause counter-rotation. And this is the ball radius and container radius. The reason I didn't do too less and too much is because it wouldn't result in counter-rotation. But I can't really see, although I can see this incline, but I can't really see what's happening in this picture. So since I think it's related to the quantity of balls, then I rated it differently. I used the container area divided and the ball area proportion, like the ratio. And it became a flat line, which is quite interesting. But there's still 3D lines. Why is that? So I thought, oh, I forgot to consider the mass. As the radius of the ball changes, the mass is 1 to 8, but the area is 1 to 4. So I changed the ball type into also 1 to 4, and therefore and it became into like almost a straight line. So I believe that in a certain ball area and ball which is quite cool. But I failed to do other experiments about this, like if I change the solving speed or if I change different ball area and wall mass ratio, what would happen? I failed to do that, but I found out that this is something, and I defined this as the boundaries of defining it as a cluster or not. And my third experiment was that since friction is very important, so I altered the different container material and different coefficient of friction. And there's a tendency that it's going down. And also, so it's actually negatively correlated. So my third experiment was I could get a result that the coefficient of friction and cluster angular velocity are negatively correlated. So my conclusion will be, in a certain ball, how do I define cluster? In a certain ball area and ball mass container, there will be a certain container and ball area ratio, which in this condition, I can define it as a cluster. And in container solving speed and container velocity are positively correlated, like mostly positively correlated. And so the container solving speed goes down, then it will be easier to calculate. And the coefficient of friction and cluster angular velocity are negatively correlated. So when the coefficient of friction goes up, it will be easier to calculate. And that will be the end of my report. Thank you very much.
Paula, you can answer important questions now.
And is the container steady rotate?
Yes, I use the machine.
And what is your initial condition for all the balls? You put it random in it, or you have another disk to you. Is it random?
Quite random.
And how did you define your transition zone? Transition zone means it's between the clockwise and reverse.
Easy state, your problem.
I'm going to tell you later. And what is the main cause for this experiment? What is the main cause?
Cause of what? Counter rotation and rotation?
Reverse rotation. Reverse rotation.
Reverse rotation. This is because of this picture over there. When this speed is slower than the speed that the container, the country centrifugal force.
So it's centrifugal.
Yeah.
Oh. And the same kind of rotation is a regular rotational motion. That means if a particle is too much, and you will have maybe one layer, second layer, third layer. So it's all layers, the rotation is the same.
No.
No. Okay. And so when you calculate what's the frequency, so which layer do you calculate for
the most outside?
The most outside.
Yes.
And what do you? Oh, okay, the most outside. And have you when you analyze the angle and do you think the friction between the wall and the ball is important?
Yeah.
Yeah. And for the mass, you said that it is important, right?
Yes.
Why is it?
Well, because the mass affects the normal force.
Oh.
So
Let's say if normal force and also centrifugal force. Centrifugal force also related to the weight. So
I'm not sure.
It's a time of the opponent's preparation. forum is ready. So you can start your presentation and the discussion.
And hello everyone, I'm the Typt from PF3, and today I'm going to proposing problem number 15, pancake rotation. For problem statement stated, we have to investigate how the direction of movement depends on regular trajectory for the reverse rotation. So we will mainly focus on explain the reason for reverse rotation, investigate the situation for clockwise rotation and reverse rotation, and how does the parameter affect the frequency and angular velocity. For overview of the report, I have demonstration video which shows the rotation and counter-rotation. And for force diagram, and they have very clear centrifugal force, Fourier force, normal force, and also friction force. And for theory, they got the force diagram and lots of amounts of force C is as a fixed cluster. And for the ball movement, the path track of the ball movement clockwise and circle around the container and doesn't touch the wall of the container. And also hypothesis. And for their experiment, they got three kinds of variable. First one is the number of particles and friction coefficient. And friction coefficient means it means the friction coefficient between the particle and the container surface. And also the rotation speed of the container. And for conclusion, and since the number of particles become bigger, and the reverse rotation will become more dramatically. And the friction coefficient of since the friction coefficient of a container surface become bigger, and it will rotate in the same direction with the container. And since the angular velocity of a container become bigger, and the particle cluster will rotate in the same direction with the container. For some advantage and suggestion, they experiment the phenomena in detail, and detail show how the balls rotate and the condition when lots of balls like a big cluster. And explain the force diagram of the ball in detail. So centrifugal force, Fourier force, and of course normal force and many friction force. And some suggestion. They didn't explain why the centripetal force for the formula would fit the experiment data. And maybe they need to use their force analysis to find what's the formula of the force and to connect with their experimental data. And didn't explain the deviation between the theory and experimental results. And the counter rotation and the rotation motion didn't be considered in the experiment parameter, the same as the transitional. And the reporter, they have to experiment they have research on reverse rotation and clockwise rotation. But I think they need to clearly more discuss about what's the transitional. And for some point to be discussed. For their theory, actually they do a force diagram, but they do a force analysis, but they didn't say what's the observer. So I will discuss the force and force analysis. And maybe some directions should be discussed. And the correlation of particle cluster. And the experimental number of particles and how angular velocity affect angular velocity of a container affect experimental result, and the friction between the container and the ball, and how can it connect it with the experiment or with the theory. And could you please try to say that you have calculated what's the friction? Maybe in your experimental
case.
Yes. So, what's the formula? It means when the first particle for n particle, but you have stated you only observe the outside, the most outside layer. So, you use this formula to what?
This formula is to express theoretically it can be formed into this formula, but the real the way that I used was that I tracked 5 of the balls in the outer boundary area, and then I tracked its omega, and then after I tracked its omega, I had an average, and that would be the average omega of the cluster. Although there might be errors, but I think 5 experiments is actually quite sufficient enough to explain.
So you see that in a more inner circle, and the particle evolves to a reverse rotation or not? Will it
do an inverse rotation, or why don't you consider about it? You only consider.
Because I see as a state cluster, and the cluster moves, the omega will be the same.
Oh, you think? Oh, you assume that it's a final cluster, so that rotation better. And could you do the first diagram of backboard again? Thank you.
Backward?
Yes, yes. The first side for your centrifugal force and the centrifugal force, and also what's the object? What do you do? So you can here, and because the object.
You want a cluster or one ball?
This only gives me a container, and what's the object of the container here? And
You want the orbit?
yes,
Okay.
orbit of the container.
This is the orbit of the container. This
Yes.
way, counterclockwise.
So here, it may rotate like this, right? So how did you know what's the direction of centrifugal force? How did you know it? And what's the direction?
From this outside.
Yes. So here. So how did you know the curve area? For example, here I have a average. Yes.
It should be like
What's the direction of curve area?
it's speed movement. Like if it's this, if the v is this way, it'll be in any direction this way. Yeah, this is the correlation. This is the velocity.
Yes, this
Direction.
Yeah, this is the velocity.
It is.
So omega is like this. So omega cross. So you think this is like the curve area.
Yeah.
And how can you do you know how to calculate the curve force and also centrifugal force, because it can react into the
I know how to calculate that.
and then write this.
This is centrifugal force.
Yes.
Is it for your letter? I don't know.
Curve is and here is why you say omega cross. So maybe you can explain this to your student and actually later. And what's the direction of friction force?
Where? Which one?
With the wall.
The wall?
Yes. And using the container surface, and you will have a friction force, right?
Yes, yes.
And so the friction force is the force for the sigma for the centrifugal force and centrifugal force is the direction of friction force, right? For the surface.
Please pardon me?
And could you please tell what is the direction of friction force in the container surface? Yes.
Okay.
Container surface. Yes. Maybe this is wall. Oh, container surface. Yes. In container. If I change
The bottom of the container.
maybe here, because you're kind of has
Is this one or bottom?
bottom.
Bottom.
So I think
I don't believe since I'm already this way.
so you think it is the same direction with the velocity. Yeah. But I think the direction should be, for example, this is the centrifugal force, and the Courier's force is so it should be.
I believe it's because I believe this background is like with the container. There's nothing moves. Nothing moves. Like this is the and I move this. It has a torque this way. Then usually the bottom of the container gives the friction this way or that way. Like this thing moves this way. Then what makes it move? Friction. So it's also this way.
And so for the direction, for the friction force between the wall and the particle. So do you think it is a force that helps the particle cluster to rotate, or it is force?
Kind that effect is a centrifugal force, which is also which is more effective because of this time. It's more effective. Like the drawing I drew before. This first this affects more, and this minus, like this is helping it this way, and this one is helping it this way. So when this minus together, you will have a formula, like a pattern of effect, which is helping the same.
You mean? And what's the main cause for this? What is the main cause for this? What's the main cause for the angular velocity?
Angular velocity of what?
Angular velocity of particle cluster. Friction. But I think it may be the density of a particle. I mean, how many particles in a container? So when the density is bigger and it is harder to move slowly, so it may influence the angular velocity.
I agree on your point, but I believe that density also affects this part. This is the container, and this is my cluster. So the R will first be smaller, like when the density is lower, then this cluster might be smaller. So this R will be bigger. So the force will be bigger. But when the ball is bigger, this is smaller. The T-ax is smaller than the zero.
Oh, I feel like
it's the same way I think.
And here, when we discuss about force diagram, we are in the non-inertial system.
Yes.
But why don't you use the inertial system to explain it? And when you in the inertial system, can you see the reverse motion?
Of course. Yes.
Not in the inertial system.
Yeah.
Inertial system means the observer sitting in the container.
Yes. Like if I'm standing.
But I think if we are in the but I think if we are in the we only in the non-inertial system and we can see this result. But if we don't, we can see. I think it is because of the vertical force.
In the inertia thing, we can still see. Like I'm in an inertia frame of reference, yes. Right? And I see this rotate. I can of course still see rectangular rotation.
But I think it may be a rotation. It may be a clockwise rotation. Because your combination rotates more quickly and
this doesn't change the force. Like different points of perspective, does not change the force. We are just adding this to explain why. Explain the non-inertial frame of reference.
Oh.
These forces are added to explain
the
concept.
Non-inertial system is the best way that we can observe it.
Oh yeah.
And have you observed the collision of the ball? The collision of the ball. Yes, thank you.
Hands up. Opponent, start to summarize the discussion.
For first one, we have discussed about cluster rotation frequency, and I think the frequency should, and maybe reporters shouldn't use this formula because they only consider about the most outside layer. So they can use this function. And for force diagram, the directional center for centrifugal force, Fourier force, and friction force, and the convention of the friction force. And for relative angular velocity between the container, that is because we are in a non-inertial system of an observer. So that the motion of the force would seem to be the clockwise rotation and reverse rotation. And between them, it should be a transition zone. It should be a transition zone between the clockwise rotation and reverse rotation. And if the observer is not at the inertial system, and we can see the reverse rotation.
Time's up.
Yes, thank you.
Reviewer, you can start to ask questions to the reporter and the opponent.
Yeah, that's what we should discuss about. I believe that when
I'll skip to the next question. So when the ball collides with the wall, will it gain energy or will it dissipate energy? Okay, so to the opponents, do you agree with that?
I think it will because it will make the ball more it will make the ball more likely to rotate in the clockwise direction.
Okay, so to the reporter, do you think the initial position of the ball will affect the phenomenon?
in some cases, yes.
Some cases. And do the opponents believe?
Yes, because it will cause a different layer.
Okay, so since you have mentioned friction, then is it static friction or kinetic friction in this phenomenon?
Kinetic friction.
Okay, so so do you consider the collision between the balls in your experiment?
In my theory, I see that as the balls in the cluster, and we cannot like simply trace every single part of the colliding thing. So I believe it's too hard to control.
Okay, so to the opponents, do you believe that it is an important factor to consider?
Yes, I think it will affect experiment results.
Okay, so to the reporter, if the mass of the balls is changed, like it is have bigger mass, then what will it mainly affect? And to the opponents?
I think the mass it will mainly maybe it will even smaller because I think it mainly depends on what's the density of the whole container.
So it will it affect the direction of the movement?
You mean direction? Maybe not.
Okay. Also, to the reporter, is there any boundary limits for this phenomenon?
Yes. Please turn to. When the balls.
Can you give a short answer?
A short answer will be over like the ratio of the container radius and the ball radius is over like 30%. Then it will never result in fracture.
Okay, thank you. So how about the opponents? Is there any boundary limits?
I think it will have boundary limits. Because when we add too many particles in air, the density will be too high, and it will be a stall.
Okay, thank you. So
Time's up.
thank you.
It is a time of the reviewers' preparation. Reviewers ready, so you can start your presentation.
Honorable juries and fellow competitors, I'm the reviewer from Team Celsius, reviewing problem number 15, pancake rotation. So here's the problem statement. Place a few balls
balls in a round container. If you move the container around the vertical axis, the ball can move directionally with the movement of the container, or they can move in the opposite direction. Explain this phenomenon and investigate how the direction of movement depends on relevant parameters. According to the problem statement, the reviewer believes that we should mainly focus on why do the balls move in the opposite direction and how different parameters will affect the movement of the balls. So here's the review of the reporter. In the theory, they gave about the friction and also the centripetal force. And in their experiments, there are parameters about the amounts of the balls, the rotational speed, and also the movement of the balls. For the pros and cons, for the pros, the reporter gave us a clear observation video and also demonstrated phenomenon and have clear illustration. However, they didn't compare the theory with their experimental results, and also they didn't consider the deformation of the ball, as the reviewer believes that when the ball collides, it will cause deformation. And they lack of calculation and experiments about their boundary limits, since the problem statement has mentioned it. Well, the balls will move in the same direction or the opposite direction. So here's the review of the opponents. So the opponents noticed the lack of analysis with forces acting on the system, and also she pointed out that the reporter didn't explain well with the deviation. However, she missed the discussion of the collision between the balls, and also she didn't notice that there are factors missed in the theory, such as the boundary limits of this phenomenon. And she didn't notice that the reporter lack of analysis with the theory and the experiments. So first, in the case discussion part, they discuss about the direction of friction. And the opponents ask the relation with friction and the movement. And the reviewer believes that when the friction reaches a critical value, the balls will move in the opposite direction. So the direction of friction is the opposite. And for our question, first is about the energy dissipation. When the ball collides with the wall, will it gain energy or dissipate? The reporter says it will gain energy, and the opponent says that it will dissipate. The reviewer thinks that it will gain energy, since that the wall of the container is still moving, so the ball will gain energy. And next is about the mass of the balls. What will the mass of the balls affect? And the reporter says it will affect centrifugal force, and the opponent said it won't affect the motion. However, the reviewer believes that when the mass of the balls increases, and then it will increase the normal force, and then affects the friction. And friction is a critical reason for the balls to move in the opposite direction. So here's the point miss of the reporter and the opponents. First, the reporter missed the qualitative explanation to this phenomenon. And also, for the initial condition, he missed the distribution of the balls. And for energy dissipation, both the reporter and the opponents lost the collision between the balls and the balls that will cause deformation. And for forces analysis, they both missed the friction between the ball and the ball when the container is moving. And for the theory parts, the reporter lacked of explanation of the assumption of all the variables. And also, he didn't compare the theory to his experiments, and such as the deviation analysis. Thank you.
Reporter, you can start your concluding remarks.
First of all, in our presentation, we have actually explained the derivation between our hypothesis and the experiment that's the results are. And the results did quite well, as I said many times, multiple times on the blackboard. And with the discussion with the opponent, we have analyzed and deepened the discussion of friction and the force diagram. We have also talked about the non-inertial frame of reference and inertial frame of reference. And the reporter believes that we can, they think that we cannot see the kind of rotation in the inertial frame of reference, but we believe that we can still see the system. We can still see the phenomenon. And we also considered the formation during the experiment. And about the boundary discussed, I have said that the boundary, if it has been considered as a cluster, then it might be able to counter-rotate. But if it cannot be considered as a cluster, then it will never be able to counter-rotate. And in terms of changing the mass, as for the reporter, the direction would never change. And I have done experiments about it, how to change the mass, but it will move slower. Like, no matter if it's counter-rotation or rotation, it will move slower. And that would be the end of my presentation, and thank you for all your reports and discussion.
Now it's a time for Jerry to ask questions.
So, if there's only one ball in the container, do you observe the transition from rotation or not?
It will always be rotation. It will never be able to catch rotation. Yes.
How do you think?
I think it will be a clockwise rotation.
There will be. What do you think?
So if there's only one ball in the container, I believe that it can still move in the opposite direction, since that friction still exists, and when the angular velocity is big enough, it can still counter.
May I explain more? Because there is only one ball, so it is a low density of it. So I think the motion is dependent on the density. If density is higher, that means it is more hard to move. So it will prefer to stay at the same place. And we have an observer in a non-initial condition, in a non-inertial system. So we will rotate. So when we rotate more dramatically, and we will think the balls only do the clockwise rotation.
There's a question for three of you. So let's assume we have extreme case. Okay, now you have balls. Okay, let's assume we have a very, very small balls, lot of very small balls in a container, like a water molecule. Okay, so now you just throw your glass. For example, you got a glass of water, then you never see the water rotate along counter rotation direction. So why? I mean, based on the theory or anything you show here, why we never see this phenomenon?
I believe it's because it is not a rigid body. In my assumptions, I see the cluster as something close to rigid bodies. But this thing, if the particles are too small, then when the particles are too small, then they might stack up or be stacked up this way, and or the other might become like they might stack up. So it's not rigid. So it will not never come to rotation. It doesn't fit my assumptions.
You can take off the mask.
When the balls is small, and then it will tends to be like moving, right? Do you mean that?
No, just keep going.
Okay, so when the ball is small, then the friction between them is small, so it's not that easy to cause counter rotation.
And I think in a fluid, as the main particle in the fluid, and it will depend on, because it's fluid. So if it have a section that is related to viscous, so when it related to viscous, it will related to a friction force. So all of it will do the co-directionally rotate.
Okay.
Can I explain more? So if it is like water, so when we move the container, you will shallow parts and the deep parts, and so it is hard for us to observe this phenomenon, but it actually happens.
So you can take off your mask. More questions?
Did you say something about self-speed?
This thing?
Yeah,
Just to explain what I meant. This picture is just to explain when I can see the whole thing out of the cluster. So it will, I'm calling that it will rotate this way along and this way, like both ways. This is just to explain.
Also, the self spin here, does it mean the spinning of the ball or something else?
The spinning of the whole like cluster.
Oh, okay. So, more questions? Now it's scoring time for theory. So now let's show the score of the reporter. 7, 7, 7, 7, and 7. Show the score of the opponent. 7, 8, 8, 7, 6. The score for a reviewer. 8, 9, 7, 8, 7. So, any comment from Julie?
I think two things to point out. Because I asked you whether if there's one ball, and you say you did experiment, and you say you will not observe this counter clockwise. Then that means that this phenomenon, counter rotation, is due to many body effects. Collision.
I explained it.
And you say yes, right? So that means this phenomenon actually can be analyzed using one body phenomenon. You should point out this one.
I mean, I point out what I meant in my project.
And all the relevant discussion about non-initial frame and coriolis force are not important. That's the key point. The collision, if that's your experimental result, and you actually had disagreement anyway. But your experiment says that this phenomenon is actually all collision, and you say it's not. That's the key point.
You can discuss it with the environment. So not just Julie give you a comment. So let's take a 10 minutes break. Reporter.你们现在不需要，你们想要你先选，你先选。
Problem number 2.
Problem number 2.
We reject.
Reject. For opponent. 那他 reject。又接受了。
要解锁吗？
哦，会解锁。
他解锁会开出哪几题？就是像6题啊，
要5个以下，要5个以下，不包含5个。
Problem number 4.
Okay, with accepting.
Assess. So it's the time of the reporter preparation. Second, please write down the intensity on the record. Recorder, text the floor, please.
Hello everyone, I'm Hello King, and I'm Philippines, and I'm going to report to you problem number 4, line, and we'll mainly focus on why the color green can be seen in a non-inset angle and why we need a line instead of a straight. And this is the inferior video, and you can see that in the video. We go around the CD and found out that the color will change in different directions. And this picture is about we use LED flashlight to illuminate on the building and it reflects to the wall. And you can see that in the power statement I took a picture of green and there is a lot of green on this. So how do we know which kind of green we want? We use the camera to take photo of it and put it into image there to find the RGB value and use this formula to change it into X, Y, Z and know the X and Y and put it into this diagram. And you can see that green represent is 495 to 570 and we can know that with the western increase, it will be much greater. Okay. And why we see a line and in what condition we can see a line? When the S is the light source, O is the observer, and T is the refractive point. When the incident angle is equal to the refracted angle, the observer will see the line in the middle of the light source and the observer. And why? This is because I can only see when the angle incident is equal to the angle reflection. And we all know that CD has several kits on it, so it can record data. And when we use Wi-Fi to illuminate it on the DVD, we can know that it can separate the color, the white light into different colors, so it can be seen as grating. And what is grating? Grating and optical complement with a characteristic structure that different light into several things, traveling in different directions. And this is the formula of it. This model to sin theta I minus 4 plus sin theta n equal n lambda. And this is the what of this. And delta I is the incident angle. You can see that. And because light will be diffracted by the grating, so we have the diffraction angle on this. And in the intention, it can be positive or negative. And it represents the number of the bright band, and lambda is the wavelength. And if we set sin theta as 0, and we can rewrite the formula by d equals to sin theta n equal n lambda, and by the sum mass transform, we can know that n is limited because the diffraction angle won't be bigger than 90 degrees, so sin theta n was smaller than 1. And in the Fraunhofer diffraction, we use Daniel's numbers to know that it is the Fraunhofer diffraction. And Fraunhofer diffraction is used like parallel light. And we have the light intensity in this. And the intensity is equal to single slit diffraction molecule in spirit. And we can know that the amount of the slit will affect the intensity. And the next one we do the experiment about the laser. Because we know that in the experiment video, I show you the rainbow on the wall. And so we do the experiment. And when we do the experiment, we found out that CD has 7 stars. Because due to the grating formula, we can know that this 7 stars is present. N equals 0, positive or negative 1, 2, and 3. And unity has 3 stars. And the sense we use the grating formula to prove it and know that these 3 stars is confined. N equals 0 and positive or negative 1. And why it has a difference of it is because this diagram is 1.6 UN and the divided square is 0.7 N. And by doing the experiment, we can know the range of green, the red or the green. So the first we implement it to the DD front, and then that is reflected in y equal to, and we have y1 in this, and we also found that it has y equals 3, and we have phi 2 for this, and then we know that the range of the frame is between phi 1 to phi 2, because we set our camera in this place, and the next we're gonna make it to the DD back, because when the light is not camera enough, it will have different angle in this one and this one. So we do the experience to implement it to the back. And we also know that the range of it. And then we use DVD to do the experience, because DVD and CD have different size. So we think that the range of it might be different, and it might be different too. Okay, and the experience of it, we use flashlight, LED flashlight in DVD to do the experience. And how we change the angle? We change the height. We change the angle by changing its height. And this is the result of the incident angle. We can know that in this picture, when the incident angle increases, it will be much greater. And then we put it in this parallel diagram. And we can see that the dot is moved onto the green, and then it goes back to the blue. And why causes it? The question from left is as the answer. You can know that this is the theory value, and the incident angle won't increase when the lambda increase. The incident angle increase, and then when they increase and decrease. So it has a circle of the line color. And the circle is blue, this one, green, red, and red to green and blue. And why the incident angle considerably? Because you can see that in 80 to 90 degrees, we can see curve not touch the red. It just is mostly in the green part. And in this example, to change the diffraction angle, and it can be seen at a view angle. We change the distance between DVD and the camera. And if it is the result of the distance, you can know that the angle decrease, it will be more greener. And we know that violet wavelength is shorter than red wavelength. And it can be seen in the diagram. And it also has a vector on it. It will first go to red. You can see that. And then it go to more greener, and then it go back to the red. And it also can be explained by the diffraction grading formula. So it also has a texture. It will first go blue and green and red, green and blue. And this is the next experiment we do this. We found that the color will change when we go around the CD. So we do the experiment to know it. And this is the experiment we do that. And you can see that if the angle increase and it first goes blue. And I draw an arrow on it, and you can see that in 1, and it goes to the blue, and then it goes to green, and it has to go to red, and it goes to the blue, and then goes to green, and this is the circle. By using this formula, we can know that it will be the wavelength will first increase and then decrease. And for the angle and new angle. And the power statement says that if not incident angle, it will be more easily considerably, and we prove it too. And so that is the experience to range to see the streamline of smaller than DVD because the thick one is DVD thick one is smaller than CD, so the angle A will be much bigger than it. And then we had a second of it. It was purple, blue, green, red, green, and blue. And thank you for attention.
And both of you can take off the mask. Opponent, you can start to ask the reporter questions.
Since the problem statement mentioned that the green line can be observed, did you define the wavelength range of the green line?
Yes, we define the wavelength in the green line.
Okay, thank you. Do you think the line will always be in the diameter of CD?
Yes.
Okay. And is filament like a continuous spectrum or discontinuous spectrum?
Can you say that again?
Is filament lines, which the problem statement mentioned, and is continuous or discontinuous? Okay, thank you. And you mentioned that you use LED flashlights in experiments, right?
Yes.
But the problem statement mentioned that we need to use a filament light, which has a different spectrum.
We know that this won't affect it.
So you use
the
LED, right?
affect it from
Sorry.
the color from.
So you use LED, right?
Yes.
Okay, thank you. Then, which part of the spectrum is more sensitive to human eyes?
This
So the green parts of the spectrum.
yellow and green part.
Okay. And do you think the distance between the camera and the filament bulb and also the CD could affect the phenomenon? The distance between the CD. Sorry.
Can you say that again?
Do you think the distance between CD and your camera can affect the phenomenon?
And it also changes the diffraction angle, so I think it will affect.
So we didn't change the diffraction angle, we only changed the distance.
You change the distance and you change the diffraction angle.
But when the same, okay, I will discuss in the discussion. And do you think the white balance or the photosensitive elements that the elements of camera will affect the phenomenon?
I think it maybe will affect it.
So you can
Answer. It is time of the opponent's preparation. The opponent is ready. You can start the presentation and the discussion.
Honorable juries and fellow competitor, I'm an opponent from Team Cells here, and I'm opposing problem number 4, power line. This is a problem statement. When the compact disc or DVD is illuminated with light coming from a filament stem in such a way that only rays with large angles of incidence are selected, a clear green light can be observed. The color varies upon slightly changing an angle of a disc. Explain and investigate this phenomenon. So according to our problem statement, we mainly focus on why only specific colors were selected, and why the colors vary by slightly turning the disc, and what is the composition of that light. So this is the outline of the reporter. So he mentioned the light path difference and the wavelengths of the color in her theory, and also the grading formula. However, in the experiment, he changed 3 different parameters: diffraction angle, incidence angle, and viewing angle. However, he failed to fulfill the problem statements that the problem statements asked to use a filament light. However, she used the LED flashlight. Then in the error analysis part, because she didn't compare the theory with the experiment, so she didn't analysis this. She didn't have the analysis of this part. And here are strong and weak points of the reporter. So he explained the phenomenon well with a clear observation video, and also he explained the theory and the quantitative explanation. However, he lacked of introduction to the environment, since this is a problem about optics, and the environment matters a lot. Also, he cannot explain the CIE coordination well, which I will discuss in the discussion. Then, she didn't do enough experiments about different parameters using CD, since she mentioned that she used DVD, and I suggest that maybe she can use CD to optimize the experiments. And she cannot control the control variables well, because he changed the viewing angle and the other angles will also change. And the lack of comparison of CD and DVD, and should mainly focus on the filament side, since the problem statement mentioned. And here are the points I'm going to discuss in the discussion. So first of all, in the structure analysis, I'm going to discuss about the difference between CD and DVD. How is the structure of the back of a CD affect the phenomenon? And also, I'm going to discuss the different parts of each CD, like this part, the top part and the bottom part. Well, there exists a color variation for different parts of the CD. Also, I'm going to talk about an analyzing method, since she used CIE coordinates to analyze. So I'm going to discuss the limitation of CIE coordinates. Also, how she obtained dominant wavelength by CIE coordinates. And I'm also going to discuss about laser calibration, which I suggest that this is a better way to analyze the wavelengths. Then in the experiment part, I'm going to talk about the setup, including a distance, because distance may be a requirement to fulfill in this experiment. Then in the setup part, I'm going to discuss environment and filament stem. And with tilting angle, which the problem statement mentioned as the angle that the CD tilts, and also the rotating angle. And in the explanation part, I'm going to talk about the qualitative first. The uneven surface that causes the phenomenon, I'm going to discuss about it. And is there a possibility that the color might be the composition of different colors? Also, the theory part. And the deviation analysis, which you didn't mention in the report, I will discuss about the white balance of the camera, also the photosensitive elements of the camera. Thank you. Sorry, can you change to page 4? Page 4. Okay, and I'm going to discuss the meaning of the CIE coordinates. So there's the x-axis and y-axis. Next page, please. There's the x-axis and y-axis of the coordinates. Can you explain what is the meaning of it?
Oh, x-axis is the part and
so it's related to the RGB value.
Oh yes, we found the RGB value and use the formula to change it into x value.
And so you can find out that there's a wavelength from this part to this part.
Yes.
And however, there's no wavelength in this part. Can you explain the reason? by this limitation of CIE coordinates, how do you analyze the color purple?
Oh, I analyze the color.
Because
we didn't use this to.
So you believe that the CD
to
can.
the wavelength.
So you believe that the color cannot be purple on the CD?
I think it can be on the. Purple is not
So,
obvious to see on
okay.
the CD.
Let's make a question clearly. So can the color on the CD be purple?
It is hard to do that.
So
It can be purple.
okay. Since the reporter mentioned that the opponent thinks that there might be color which is purple, but however the purple light is non-monochromatic, which is composition of red and blue light. So we can use laser calibration to analyze the wavelength in this part. Do you agree with my method?
I don't agree with this because it's hard. It did not have a single light.
And can you use a prism to separate the lights into two different colors?
At this part, I think it's not important to discuss about other colors.
Also,
because,
so for color purple is not important.
yes. Because
Okay, the opponents disagree with that since the color purple will also be on the CD, and it's also an important phenomenon to discuss.
And I think that color standards tell us to investigate the frame. So why should you have to discuss about the purple?
Because the color standard mentioned that the color will vary upon slightly changing of this. So the color statement is not limited to the color grade. Okay, I would like to skip to the next question. Can you explain why it says a single color instead of like various different colors? Because like when we see in this environment that there's various different colors. However, in your experiments, there's only one color. Can you explain that?
Because our environment is not enough to that it has one single light.
Okay. So since can you explain that do you agree that there might be the color might be a composition of various different colors?
Can you?
Like the color purple is composed of red and blue light. Do you agree with that?
Yes.
So okay, so you agree with that, right? Okay, the opponents would agree with her answer, and I believe we can use a prism to separately color and analyze the wavelengths. So that won't be limited by the CIE coordinates. And can you explain that why is it a line? Or is said that there might be an area full of color? Why is it a single line?
I think it is because the incident angle equals a different angle. So we only can see a line, and due to the reflected law, so we can know that I only can see when angle is the angle.
The opponents agree with this part, since the distance between this line will be the same with the line with the observer, also the line with the light source. Okay, and do you think that there might be a possibility that the line cannot be in the diameter, or the light can be on this part? Do you think there might be a possibility?
I think so.
No. Okay. Can you explain what is the reason?
Oh, because we made sure that it didn't go like this. Have you ever seen the line on this side?
Like this part, there's multiple lines that is not on the diameter.
But you can see that yourself.
Well, perhaps we can.
Diameter is the diameter.
I'm sorry, can we use the password? So what I mean is that, so I assume this is CD. So the line, will the line be on this part instead of on the diameter of the CD?
You didn't see.
So do you think there?
The line will be like this.
So
You take the compact this, compact this and have several lines, right?
yes.
And it's almost like this.
So always on the diameter.
Yeah.
Okay, the opponent agree with this part. viewing angle, but like when we view a CD from this part, so the angle between this part and this part of a CD will be different. So how do you ensure that the viewing angle is the same with different parts of the CD?
We need to transfer the distance. The distance not differ enough that we
So the distance might need to be far enough. Okay. The distance needs to be far enough. Okay. And how about the camera and the light source?
The camera can be seen at a lighting is fine, and we have to be far enough. And so does the light source.
Okay, the opponents disagree with that part. I partially agree with the CD and the observer. And because the distance needs to be long enough for the difference between viewing angle to be ignored. However, the distance between the camera and the filament stem need to be short enough to ensure the angle will not change. Do you agree with that?
Yeah.
Okay, thank you. And you have mentioned that there will be difference between CD and DVD. Can you talk about that?
Oh, and the big one difference is different. You can see that in UV and.
So, well, what will the phenomenon cost? What will it cost? Yes. Okay, thank you. So, you believe that is a distance between CD and DVD?
We have seen on this, and the space between CD and DVD is different. So it will affect them.
Can you explain what is the light path difference in your theory? So the whole thing is a light path difference. Okay, the opponents agree with this part. And I would like to discuss about the light source. Since you use LED lights, right?
Yeah.
Can you explain what will it cause an experimental error if you use a LED except of filament stem as a purple stem mentioned?
I think that it won't affect color, but it will make the green become
It will affect
greener.
color. However, the spectrum of the LED lights is like this, right?
Yeah.
And it mentioned that the spectrum of filaments is like this.
Yeah.
Then the spectrum is different. How will the color be the same?
I think that because it had a front, it had a color, it first goes to green red, and I think that it might that the green
So
become more greener.
Okay, so the color will be different, right? Because you mentioned that green will be more significant.
Yes, it will be different, like green, and then it more greener.
So the color will be
It
different.
will change into different colors.
The opponents disagree with this part. Since she mentioned that the green will be more significant, so the wavelengths of the color will change. So using the LED lights and filament flow will change the phenomenon. Thank you.
The opponent start to summarize the discussion.
Honorable juries and fellow competitors, this is a summary of my discussion. So in the first part, I discussed about CI coordinates. I discussed, and I agree with the reporter since he should use RGB value to get the wavelengths of the color. Also, there is a limitation to analyze the purple color, which the opponents believe that we can use a prism to separate the color into various different colors to analyze the wavelength. So the CI coordinates, so it can solve this problem. And we can use a prism, right? And the angle between the observer and the light source needs to be the same. So the distance between the observer and the light source needs to be small enough. Also, the viewing angle between different parts of a CD will be different. So the requirements to fulfill in the experiment is that the distance needs to be long enough. Also, I discussed about a comparison between CD and DVD. And I believe that there's an experimental error from LED light. Thank you.
Reviewer, you can ask questions to the reporter and the opponent.
And first we were first talking about whether refraction angle is equal to the distance angle. You said that this is the only way to see the one. Is that so?
angle is between 80 degrees to 90 degrees. It's also almost under full.
So how do you define large angles?
I disagree with the reporter because with a problem statement, it's mentioned that with a large angle, a clear green line can be observed. So I believe it depends on the color of the CD. So the angle will change as the color varies upon turning the disc.
Okay, so do you consider the difference of proof instance between the CD and DD? Like the distance between the three is actually different. So this is one constant.
You mean the thing one?
Okay, I can skip the question. So you didn't really compare the colors, which is also stated in the problem statement. Is that so? By slightly changing the color, so you only see the green one. You only observe the green one.
No, I also observe red line, and purple line.
So can you show your data? Okay. I think we can move on to the next question. So you think the light of the incidence, the color of the incidence light will affect the experimentation or not?
I think it will affect it, but it won't change the color. It will be much, the green will be much stronger than other.
Okay, so what do you think?
Can you rephrase that?
If the color of the incidence light will affect this experimentation?
The color of the incident light.
Yeah.
Yeah, since you should use a different light source, and the spectrum is different, so that will affect the wavelengths.
Okay. And that's the right question. Thank you for your answers.
It is the time for the reviewer's preparation. Reviewer, text 4, please.
Good afternoon. My name is Lulu and I'm from the team in Norman. Today the topic I'm going to review is question number 4, color line. So we think that the main focus of their the main focus will be on what color we can be seen in a large incidence angle, and also why is it a line instead of a sheet. So all of you will reported Her advantage includes various coordination of phenomena and user gradient inclusion to calculate them, which is also known as the level of diffraction. And also she is with some substantial data. And also the suggestion for her includes her demonstration video didn't seem to show green line, which is more similar to blue line. And some schematic diagram is not clear enough, for example, in the page 9. And she will just show the raw data of a calculated diffraction angle, and which might have the deviation, but without the error bar. And she also didn't clearly explain the observation when the level of diffraction is different, since you have mentioned about. And also, she failed to fulfill the task of using the wide filament light. And also the color varies on slightly changing the angle. It is not fulfilled as well. An overview for the opponent, his advantage include clear presentation, and also he find out the detailed mistakes of the reporter about the definitions as well. And he also asked thoughtful questions about using the experimental setups, and he provided answers to their own questions as well. And the suggestion for him includes he could probably have given more time for the reporter to explain about the question. So the discussion 1, the opponent asked about the coloring measuring and the missing part. So the reporter answers since the so she first answers about it's a single light, and it's hard to make the CD look purple, and she says it's not important. But the opponent thinks it's important, and the reviewer agrees with it. And the opponent is asking about slightly changing the color, which is the task. And in the discussion 2, the opponent asks if the reporter agrees with the color can be a synthetic light, which is also what we know as the white filament light is. And the reporter agrees with it. And we also discuss about the difference with the CD and DVD, and which the reviewer agrees, since the which what we show in which we see in the grid equation, which is also known as the group distance, can be different. So this will also cause the diffraction to be different. And for the discussion 3, the opponent asks when the light is called a light, why the light is called a light rather than not. The reporter asks and answers with the refraction angle is equal to the incidence angle. And the opponent asks about how to make sure the viewing and the camera is accurate. And I'll disagree with the reporter's answer, believe it's stable. And since some of the equipment is small. And the opponent asks the experimental error from the LED, and he believed it to be spectral effect, and the reviewer agreed with that. So we think the conclusion of it includes the color of the incidence effect a lot, and thermal light is also important due to using synthetic light for the chromostatic measure. And also they have talked about the angles of different diffraction and one can see a light.
Time's up.
Thank you for listening.
Reporter, start your concluding remarks.
And here are my remarks. For the white balance, the camera might be affected by it, but I think it is the little termination of the experimental device. Every camera has its features. Because of the tool limiting, we don't have the choice to do the experiment without the light. However, we stay to the trend and instead of the line, try to find a line that could be closer to our problem statement. And we find out that we can see more different kinds of waveform LED light source, not only blue. And besides of the green line, we also observe the red line and the purple line and other color lines. For the component, I think perhaps we can more focus on the key this point, which is the diffraction in computer, and why it projects the green line, not the EID and the purple one. And for the reviewer, the RIE cannot do the error bar. And because of the breaking and interference, we can see a line on the 3D, and the color it depends on the light source, incident angle, and view angle. And we have found a sequence of the light, the color. It will go blue and green, red, green, and blue. And for the line, I think that it is the physical measurement that
Now it is a time for Julie to ask questions.
And you can offer the answer. Do you know there's a protection layer in the CD or DVD? Do you think that will affect your vision? Quick question, quick answer, please.
Oh, I know that.
Do you think that will affect your analysis?
I think that it has a refraction, but I think refraction it affects a little. That we can ignore.
So actually, a protective layer is on the top of the bottom layer, and the permanent segment SR to incidence of light on the back of the CD. So it won't cause the experimental error with the protective layer because it's on the top part, and we incidence of light on the back part.
I think it will affect, but not majorly, since the reflection will probably affect minority light.
Let's first talk about the geometry of the surface. So yes, just keep here. So you can see that the length of the depth, okay, may relate it to because it's binary, right? So it's contains 0 and 1 and the surface of C. So the length may be completely different. Okay, it varies. Like you can have 001, 0001111, something else. So now your model, if you look at your model, you always have the same distance with your dent, and your width of the dent is always the same. So you base on this model to derive your construct interference. Okay. You have a construct interference of green light or anything else. Right? So how come you can use this model to derive your result of interference? Do you know what I mean? I mean, you can see that the dent is in different size and different distance. Okay, then how come you can use that? This is the first question. And then second question, why it's a line? Why can be other geometry like a dot? I mean, you can be interference, right? So why it's a line, not a dot, not many dots? Okay, so obvious.
By the model, I think the one is this one to this one, so it won't have the problem of that. It can this model can be used in this because the date is equal to this one to this one, right? And for the second question.
You can see the dent is in different size, right? There are holes, right? That's dent, okay? So that's different size and in different distance. And I have a point here. So you can see this is depth, right? Yeah. So you have many depths. So in this one is larger, right? The distance is longer.
Yeah.
Okay, this one is smaller. So how come you use this model?
The depth of this one, we can calculate this one to this one. That's the depth.
If so, then how about this? If you go to here to here.
I think that because we use the CD in the same CD, so it will be.
That's different, right?
So I believe that there's this part of the DVD will be different with different CD and or DVD. And then this could cause error to derive a theory. However, this is the best way we can use because it will be different between different kinds of CD and DVD. It will always be different because it's used to store the data of the DVD and CD.
Yes, but it cannot be regular.
Yes, I agree with that.
Yes. So how come the model is correct?
So I believe that because you can see the checks are equidistantly distributed. However, there's might some parts of the checks that with a larger distance, and it could cause the error. I agree that it could cause the error.
What kind of error?
Like the light path difference between this track and this track is different. So I believe that we can use a cross-track intervention to solve that. Because in the cross-track intervention, the constructed wave might generated by checks with these parts are two times distant than this part.
Okay, so
So this is why I mentioned about there's probably a deviation in the angle that should be right. But however, I think that in this part and this part, it's probably just one of the two. I mean, this part is 2 times of this. But however, looking at this transistor, this still probably happen. So this is why I asked you probably to do more types of the experimentation and ask everyone like to do it right.
So more questions? So now it's scoring time. So now let's show the score of the reporter. 76675. And the score of the opponent 77877. And the score of the reviewer 77786. So do you have any comment from you?
我们不可以教学生嘛，对不对？
No.
你要查一下那上面带什么准备就是
这样算教主任？
那
我们可以不要不可以这样。
So you try to answer this one. 好，那我们今天的比赛就到这边好，谢谢大家的参与。